And so, Michelle, we'd love to hear from you, kind of picking up on how we're getting there, the opportunities you're seeing, and any of the above questions we've been bringing up in our discussion so far. I know you've got your deck, and so we'll give a minute if you want to refer to that as well, just to pull that up.
So to pivot off of what Lucas said, the transportation challenges that we face. So low Earth orbit is interesting. It's space, but when astronauts are on the International Space Station and it is directly above us over Houston, we're actually closer to the International Space Station than we are to Dallas. That's how close it is. And people don't realize that. They think it's in space. It's very, very far away. The space station's fairly close. But when we go to the moon, that's a pretty long journey. And when we go to Mars, the round trip journey to Mars and back, and remember now we're leaving Earth and we have to change our coordinate frame of reference. So when we go to the moon's just kind of going around the Earth, right? So it doesn't really change the distance between Earth and the moon very much. But when we go to Mars, Earth isn't where we left it. So when we come back again, we have to chase Earth around the sun to catch it. So the round trip odometer reading on our vehicle when we go to Mars will be on the order of about 2 billion kilometers. That is a long, long distance. So the types of vehicles that we use to get to the International Space Station, those are a little bit too small. This is a much longer journey. We're going to need bigger transportation systems. So if you jump to page, the next page there, we've got 4 different types of transportation systems in the trade space that we're looking at now. There's the traditional all-chemical types of architectures. We're looking at some electric propulsion options, both a solar electric propulsion and nuclear electric propulsion. The nice thing about electric propulsion is they're very, very mass efficient, whereas all-chemical propulsion systems are very, very massive. And we're also looking at nuclear thermal propulsion. So those are 4 new types of technologies that we are looking at to be able to extend human presence further away from Earth than we've ever been before. The other thing that we're doing with the robotics, we're looking at things we've never really gotten to play with before. For example, the Ingenuity helicopter, you guys are all familiar with that on Mars. Conventional wisdom is the helicopter shouldn't work in space, but Mars has just enough of an atmosphere that the helicopter actually works. So one of the most fun parts of my job is I get to work with the Ingenuity team. We are looking at ways to extend that technology, make a little bit bigger helicopter, make it a little bit more capable so that we can do things. In particular, what we're interested in is crew risk mitigation. We want to make sure that crew on Mars, if they get themselves into a situation where they need a little bit of help, that we're trying to develop these robots to be able to help the crew. That's all the hardware. So if you're into engineering and hardware development, lots and lots of opportunities there. But I want to talk about one other thing, and that's the humans. The humans are a part of the system that we have to think about a lot. If you jump to page, I got a picture here that Luca will like. Page, I don't have page numbers. The technology challenges case study food science. So it's one thing to be able to get our vehicles to Mars and back again, but remember the payload is going to be the crew. And we have to keep the humans happy and healthy all the way to Mars and back again in this 2 billion kilometer journey. So food, this event is hosted by our friends from the Italian Consulate, and everyone knows Italians love food. My grandmother was Italian, she was a professional chef. So keeping the crew fed sounds like not a high-tech thing, but it is phenomenally high-tech because you're talking about very long journeys. We have to, if the food system fails when you're halfway to Mars, it doesn't matter how good your propulsion system is. You can have a fancy nuclear propulsion system, but if the food system fails, you're going to be in trouble. So it's not just nuclear propulsion that offers a lot of opportunities and challenges, but even things like food science for a Mars mission are going to be incredibly important.
And I love that you kind of left us there with this challenge, which maybe it's not even at the forefront of our minds the fact that we just had a lovely meal and that probably around 5 or 6 tonight we'll have another lovely meal. But when we go to space, not just to lower Earth orbit, the moon, Mars, beyond, these challenges can kind of pop up out of nowhere. And how we deal with them, we can't just phone home and say, okay, I need some more food, please send that right up.